Okay, so today we're back onto the AEG Belt Sander. I know it's been a little bit since I took this apart. I'll talk about some of the challenges I had with procuring some parts for this. But I just want to show you, now that we got all the dust removed, I didn't get all the grease out of this gearbox, but I think it's good enough for what I'm going to use it for. But it's still surprising to me that they used a plastic gearbox. So this right here is actually the parts diagram for the Fez tool, the current Fez tool belt sander model. And it's very similar, but there are a couple of differences I noticed when I went through the parts list here. So the first thing I noticed is they don't show any bearings on this housing that I can see from this diagram. So I don't know if those bushings that we had problems with are actually built into this housing, a part of that assembly or not. But there's got to be something in there that is riding on. I think the major differences I saw are the way that they handled this bearing over here. So they actually have a different part here to hold the bearing and the brushes, and they use constant force springs on that one. The AEG model actually just puts the bearing right in here, and then the brush holders are basically built right into the housing here. Looks like they took the AEG design and made a couple of very minor tweaks to it. But most everything looks to be pretty much the same. This piece down here is, I think, an add-on that I don't know if that was ever available for the AEG model. But we have these feet right here. So now it's time to talk about bearings. So if you remember, the main problem I was having was the bronze bushings in here were basically wallered out, especially on one side. And after cleaning this up, one thing I noticed, if you look here, it looks like there's some melted bronze right in here. It kind of went over the side here. So whoever was running this, I can't imagine that they didn't notice that this thing was basically smoking. It had to have been smoking if they got it hot enough to melt those bushings. I'm kind of surprised that it didn't melt part of the aluminum housing as well. But that's kind of crazy that they got it that hot. So this was definitely a well-loved tool. I did my best to clean this off, but some of the paint was starting to chip off, so I didn't get it as clean as I wanted to, but I think it's going to be fine. So one thing I did notice that they stamped all of the parts with the year of manufacture. So this piece right here was made in '85. Both of the housings, I'm not sure if you're going to be able to read that, but there's an '87 stamped in there. So all of the injection molded parts had a date stamp in there, so there's '84. But AEG was definitely very stringent about marking everything with part numbers. It's one thing I've noticed about all of the parts that come out of there. Even small stuff like this has their part numbers stamped on it. Here are the old bronze bearings. So just to give you a refresh on the problem, you could see there that the one side there is really wallered out. And it was more so on one of the two. This one was wallered out a little bit, but not as bad. These smaller ones really didn't see much wear at all. This is what I believe the main problem with the sander was. Remember, when you turned it on, the belt wanted to fly off the end. And I'm pretty sure it was because of this imbalance here. So I'm not sure what could cause this, if it's just that's a normal wear pattern. A couple people theorized that it might be the belt in there was tightened too much. So it was really pushing down on one side. And so basically the shaft had a lot of force down this side, not as much on here. So that kind of makes sense, because remember, this is not spinning, the shaft is spinning inside here. So there were some challenges in getting, especially this bearing right here. Because of this is such a small lip, there's only about a 1/2 millimeter lip on there, not very much at all. I was able to just procure these smaller ones, the exact same size. These are just oil light bushings. So for these bigger ones, I basically found this piece, which was the same diameter on this part, but it wasn't quite the same because this lip right here is a lot shorter on the replacements, and it wasn't quite as long, but I don't think the length is going to be an issue. But I may have to shim this. I'll have to see how everything sits together there. But I actually had a machinist make these for me because I'm not that skilled at making these on the lathe. So I basically gave him a couple of these and then this, and I told him not to worry about the actual length of them. Don't worry about taking off this end, because I don't think, looking at the housing in here, I don't think that it'll bottom out in there. Alright, so now talking about more traditional bearings. So these were the four bearings that were in here, and they were all a little bit different. So these two, well, they're the same size. One had a seal on it, so I think I can just buy a regular double-sided one and take the seal off one side. This guy, I was actually able to find the exact same model from I&A, because that's what this one was. And then this guy was really an oddball bearing, and this was the one that was basically locked up. It's a 607 bearing, which is a 19 millimeter outer diameter and 7 millimeter shaft. So it's really an oddball bearing size. So I've had some pretty good luck with this company. I guess it's pronounced Zyke or Ziki, I don't know how you pronounce that, but I had to wait for these to come in because this particular bearing, like on McMaster Carr, was like I think it was a $20 bearing just for one. So I waited, and these were on back order, but I think I was able to get 10 bearings for less than that from this company. So one thing I noticed with bearings, it's kind of it's a very reputation-based business where it's very easy for your reputation to be ruined with a bad batch of bearings. So quality control was really very important if you're putting your name on it like these guys are. So look at this, they individually package all these. And so these say US on them, so I don't know if that's actually the country of origin or not. So what you should be able to do is take the seal off one of these sides, and yeah, so now it'll match the one over here. So the other challenge I had was trying to determine if this was the correct belt for this particular tool, because I didn't really feel like that fit on there the right way. So doing my research on this, I actually came up with this belt, which is even thinner, a lot thinner than the existing one, but it was the same size, had the same number of teeth, but it does look like the old belt was really starting to wear out, because if you look at the teeth pattern here, it kind of was flat on the bottom of these. Whereas if you look at the pattern here on the actual sprocket, definitely not flat, it's more round. And you look at these are a lot more round. I don't know if that's just wear on this guy. It just wore that down. So we'll try using the smaller belt, even though it seems like it should be a lot wider than that, but We'll see what happens. I don't think there's going to be any danger in using the smaller belt. I guess the final problem I saw was there was a gasket in here. It looked like it was a silicone gasket. It basically seals up the gearbox compartment that was really damaged. So I saw a couple of things I could have done. I could have bought some O-ring stock and kind of cut that to length. So in this case, I think I'm going to use something like RTV and just basically use a gasket maker. I typically don't like using gasket makers because, especially for this older stuff, the engineers, a lot of time when they were designing a product, they were relying on a certain gasket height to maintain clearances with other, pieces. So if they needed this mating piece to be a little bit taller, they may have put a thicker gasket in there. But I think in this case, I think it was originally made with a kind of a gasket maker type thing. If you look at the corners here, they're very sharp. Whereas if it was a kind of O-ring stock, they would have made these corners a little bit more rounded. So this is one case where I think I'm going to use the gasket maker. And I know I don't need high temperature rated stuff, but I'm just using the red because it's easier to see than the black, because then I can see all the places that I got it in or I missed. Alright, well I feel like that's should be good enough. So we'll go ahead and let that cure for a while. And remember, there's raised things on here, so it'll be pushing into it. So I think that should be good. Got those bearings pressed in on either side. And I also put the shaft in here. And I think this shaft may be bent because there's quite a bit of resistance still. Even after making the adjustments, this is about as good as I can get it. I can't turn it by hand, but I can turn it with some assistance. So it may have been the cause of the failure was this shaft being bent. But I did put a drill on this end and indicated on here, and it was running pretty true. So I'm not sure if it's the housing, maybe something in there is bent. So, but I think it's a pretty easy change if we can even get this part to replace that. I don't think you got to take apart the whole sander again. So I guess we'll go ahead and pack this gearbox with just some standard lithium grease. I went ahead and just slipped that bearing on. So we got on one side it's basically open. On the other side it's sealed. So I had to go back and watch the teardown video quite a few times when building this section. There's just not some things that were intuitive to me, like this piece right here, this black piece, which I'm not even sure what it does, but that was right there. And then to get the shims right for this guy, but I feel like I got everything good. Check the brush pattern on the brushes, they look okay. Had to make sure I had the routing right on this because it's kind of complex. So like this connection actually goes over to this brush and vice versa. The other one goes underneath. And then we got our two wires coming up through here. So one of them goes to the circuit board. The other goes to the switch. I'm basically going to try to finish up this entire bottom section and then power it up. I don't think I've ever run into a tool like this where this part was basically segmented from the rest of the power tool. So you could probably use this for something else other than a belt sander. Because essentially what you're getting here is you're getting a drive output, and it's adjustable RPM using this this board right here. So these could easily be repurposed into some kind of other power tool, anything that was belt driven. But I must say the systems engineering on this is quite good. So it's typically there are two things that happen here. The mechanical guys design it and say, hey, the electrical guys need to design a board that fits here, or they work together and decide how they're going to make that little section there. But it's quite a good solution they found there. So I think we're ready to pop this section back on. Hopefully everything lines up. Alright, well, I got that cover on. It took me quite a while to get everything kind of lined up perfectly. But I think it's on there the way it's supposed to be. So I think next thing I'm going to do is put the brushes in, and then we'll wire up the switch and the power cord, and then we can test this basically the motor portion of this. Alright, now onto the switch. This thing still kind of sticks a little bit. I cleaned it up as best as I could, and I put some electrical lubricant in there as well. But it just kind of binds when you press it to one side. You press it on... So I don't know if when I was cleaning this, if this got deformed. It sure looks like that one side melted. Not really sure what happened there, but I did buy a new power cord for this guy. So we'll go ahead and get this cord grip installed and put the cover on, and then we'll try powering this thing up. So one of these screws was stripped out, so I had to go get one a little bit longer. Alright, let's go ahead and test this thing. Yeah, I still got a sticking power switch, but that's fine. But looks like it's working. Alright, so now we're going to put on this idler wheel assembly. So I was looking at my hardware here, and it didn't look like I had the right screws, so I think this is the one that goes in here. I went back and watched the video. That's the one that came out, but I only have one of them, so I don't know what happened to the other one. So I went down and I found some comparable units. These are just sheet metal screws, so I think anything will do. So you basically got these two screws holding the whole assembly on, and then there's a different part that's spring-loaded that kind of floats in there. So then we got this shaft on this idler wheel, and this is a pretty loose fit, if I remember. And then this is just basically a thumb wheel. It's got a hex insert in there. That thing does seem pretty wallered out. But I went back and watched the video, and there was no bushings or anything in there. And I looked at the Fez tool diagram for that, and there's no bushings. So it's just the shaft, that spring, and a little piece of nylon. So I don't know if that's possibly an issue with this being too loose. To keep an eye on that. So the other thing is on this, I was talking before about how tight of a fit that was. I went back and I took both of these bushings back out and examined the shaft to see if it was bent. And the shaft was perfectly fine. The bushings were perfectly fine. The issue looks like that when they bored the holes on these opposite sides, they weren't perfectly parallel. Because if I put one bushing in one side, the shaft spins fine. Take that bushing out, put this bushing in, shaft spins fine. It's only when you put both bushings in, so I think they're kind of like, no, they're not quite on the same plane. So I did lap these bushings, so they're not quite perfectly round anymore, but that's what I needed to make this actually spin with you know, not heavy resistance, but so it's probably going to end up the same way as the old one over time. I don't really know if there's a good solution for that because it's a pretty thin housing right here. I don't really know if there's enough room to bore that out again. So we'll go ahead and put this wheel on. I think that might be easier to get to it here before it's actually on the rest of the sander. So there's a shim that goes on this side right here. And then you got the actual wheel. And then this plate. And then just a washer and a socket cap screw. That's all that holds that in there. And then the large wheel goes on after that. So what kind of threw me there was the Festool one clearly has the small wheel on top. As you can see, I'm oriented the exact same way that this is now. And like I said, I might go back and put thread locker on these once I feel like I got everything good and working. Alright, so now we'll go ahead and screw down this top section. So there were some shims on here before. So I'll try to put them in where they were before. And then we'll go ahead and put some screws in this thing. Well, it looks like I screwed up. I need to take this idler wheel assembly off before I put this piece on, because there's a screw over there and then this one is interfering as well. So we'll go ahead and do that and then we'll come back when I got this thing on. Alright, so I got that back on. Went ahead and put the belt on. Yeah, I don't really think that's the right width. So it's certainly the right length and number of teeth or pitch. So I may end up replacing that. The other one wasn't quite as wide as this area as well, so we'll just leave it in there and see what happens. Alright, so I think the last thing to put on is this this wear pad right here. I'm just going to reuse the old one. I don't see any reason to replace that at this point. So I got three screws left and one thing to put in. So I think, after thinking about this, I think I know what happened. The core grip was supposed to use these type of screws, and I stripped out one of them. I think the screws that I was using there were the ones that go up here. So it's not a big deal. If I ever need to replace those, I'll just heat set a brass insert in there and just use like a real machine screw. So I think before I put a belt on and the guard on, we'll go ahead and test everything. Make sure this wheel up here spins all right. All right, got it plugged in. Let's try it out. So that's on the lowest speed. Still not happy with the way this switch turned out, but what are you going to do? I think it's a design flaw in the switch itself. So the belt kind of walked its way back here. I think that'll be all right. It's not touching anything, and it's still on the teeth on the top and bottom side. So let's go ahead and put on a belt and see if we fixed our problem. So we got a brand new 80 grit belt here, so hopefully this is the right size. So you gotta get the arrows going in the right direction. All right, let's see if it flies off. So that sander has a lot of power to it. So I think that'll serve me pretty well. So it looks like we fixed the problem. It was probably the wallered out bushings, like I thought. But you know, I may end up putting a like a starter switch on this, some external one, because that switch is really bothering me. I could just probably push it down and tape the button, and then just use an external switch, something like this mounted on the wall or something. But yeah, I think that was a pretty successful restoration there. We got this tool working. It was in an unworking state when we got it, and hopefully it'll last us for a while. Well, hopefully you guys enjoyed that. That's it for this one. I'll catch you guys next time.